In this video, we're going to talk about the applications of the vertex. So let's take a look at the first example. The unemployment rate or percentage among individuals aged 25 and older who have a bachelor's degree or higher can be modeled by this function equation where x is a number of years after 2004. In what year did the employment rate reach its minimum value? Round this answer to the nearest integer. And what was the minimum unemployment rate? Well, let's take a look at the function. It is a quadratic function because the degree is 2. Now, the leading coefficient is positive, so I know that it's going to be opening upwards. Well, where do you find the minimum? Well, you find the minimum at the vertex. So we must be able to determine what the vertex for this quadratic function is going to be. But before we do that, we must figure out what the equation of the axis of symmetry is going to be. So remember, that's x equal to negative b over 2a. Well, that's the same thing as minus a negative, that decimal, divided by 2 times the leading coefficient, which is this number. Well, that's this over this. And when you put this into a calculator, it's about this. But we will use this number for 2. So now what I want to be able to do is to plug in 2 into this quadratic function. So we've shown substituting in 2. Now let's get a calculator to help us simplify these numbers. So when we do that, we get this decimal. But remember, we want a percentage. So this is the same thing as 1 and 81/100%. So let's write a summary statement for this. So 2 years after 2004, or in 2006, the unemployment rate reached a minimum of about 1 and 81/100%. Okay, one other example I want to take a look at. The height in feet of a ball thrown is represented by the function after t seconds. What is the maximum height of the rocket? Now, again, this is a quadratic function because it is degree 2. Now notice this time the leading coefficient is negative. So you know the graph of this quadratic function is going to open downwards. So the question is, where is the maximum for this picture? Again, similarly to the previous example, it is at the vertex. So we need to now be able to determine what the equation for the axis of symmetry is. So we'll do t equal to negative b over 2a. That's negative 48 divided by 2 times a negative 16. Negative and a negative is a positive. 2 times 16 is 32. And this is going to simplify to 3/2, which is the same thing as 1 1/2, or 1 5/10. Now, because this is a terminating decimal, I will substitute 1 5/10 into this function. Now that I've substituted this in for t, let's use a calculator to help us get a numerical value for this. And we get 154. So now let's write a sentence to summarize what we just found out here. After 1 5/10 seconds, the ball will reach a maximum height of 154 feet. Now, when you look at problems with maximums or minimums with a quadratic function, the first place I would check is the vertex.